This video is about multiplying and dividing rational expressions, and I'm going to follow a basic two-step process, the step one being factor everything completely, and step two being multiply or divide and reduce. And so let's kick things off with an example that looks like this. X cubed yz squared all over 4x plus 8 times x squared minus 4 all over 2x squared y squared z squared times 8yz all over x minus 2. And so as you can see, we have 1, 2, 3 rational expressions being multiplied together. And so given that we have more than just two, we have to use order of operations, which says go left to right when given a couple instances of multiplication. So we'll go ahead and factor everything completely. Of course, only things with multiple terms would need to be factored right now, meaning there's only one term in the numerator here. We can leave that alone. Down here, we could definitely take out a greatest common factor. This is a difference of two squares we could factor. This is one term, so we don't have to do anything to it. This is one term, and then this is, though two terms, already prime. There's no way to factor it. So really, just this expression up here and down here need to be factored. So I'll go ahead and rewrite the whole thing, but factor those. So I can write here 4 times x plus 2 as a factored form of that expression, and then up here x plus 2 times x minus 2 being a difference of two squares for that expression. I'll copy this one down, and then lastly copy this down. There's nothing else to factor. Now, how do we know things are factored completely? Well, there should be no addition or subtraction that's not in parentheses. Okay, you might say, well, wait a minute, there's a subtraction that's not in parentheses, and that's true. So what we should do is, since it's the only thing here, put it in parentheses so that we recognize that's one factor. And if that's the case, then everything really is being factored. Now, I'm going to do this once and then not every time again, but the next step really is to multiply these fractions together left and right. As you may recall with multiplication of fractions, you go straight across the top, straight across the bottom. And since everything is really being multiplied all the way across, I'm just going to write all of these factors together and all of these factors together as well. Maybe with some slight order changes. In other words, we usually put constants first, so I'll put this 8 here up in front. And then you can see we have an x cubed here. There's no other single x factor, so I'll write that down. We have a y factor here and also a y factor over here. If you multiply those together, you get y squared. And then we have a z squared and another z here, which would give us z cubed. And then these two binomial factors could be written just on the end here. Again, ultimately, everything's still being multiplied together, but slightly simplified. Then if we go down below to the denominator, we could again just pull the constants in front and say 4 times 2 is really 8. And x squared, y squared, z squared, there are no other factors that will combine with those. So we'll put those in order next, and then we'll put our two binomials. We have an x plus 2 here and an x minus 2 there. And so you might notice for convenience, I did try to keep the same order on the top and bottom for some matching factors. And in fact, now that everything is factored, again, addition and subtraction are contained within parentheses, we can cancel matching factors. This entire x minus 2 is a factor, matching that one. Same thing with the x plus 2's. And you'll notice here some y squareds cancel completely, being matching factors, and so do the 8's. Now, the factors of x and z that occur on top and bottom don't match exactly, but they will simplify. X cubed over x squared is just x, still in the numerator. And then z cubed over z squared is just z, again, still in the numerator. So these two remaining factors would be really over 1, which you don't have to write, but they are still left from those in the numerator. And that is our final response. I want to do another example of simplifying or multiplying rational expressions rather, and here it is. Let's say we had ax plus bx plus ay plus by all over x cubed minus y cubed, and that expression times x squared plus xy plus y squared all over ax plus bx. So to follow our steps, we must factor everything completely first, and so we'll start right in with that. You might notice that this numerator here on the left is 1, 2, 3, 4 terms, and seems like it might be set up to factor by grouping. You can see if you group the first two and the last two terms, the common factor for those first two terms would be x, and if you factor that out, you get an a plus b remaining. The common factor of the next two terms would be a positive y. If you factor that out, you also get an a plus b remaining. So we're going to continue with this one more step to keep factoring. But then while I'm at it, I'll start with what's below, which is a difference of two cubes. And so by the formula to factor a difference of two cubes, this should be x minus y times x squared plus xy plus y squared. Okay, and I'll do a step or two to factor the right side if possible and needed. You'll notice the numerator on the right side is a trinomial, may or may not be factorable. In fact, trying a couple different things would probably reveal that it's not factorable, but notice that this trinomial matches exactly now what we've ended up with down here when factoring. So we're going to leave this thing as is, and x squared plus xy plus y squared, and just put it in parentheses to keep it all together and remind us that that entire trinomial should be able to match and cancel with this one, hopefully, when we're finally near the end. Down below here, we can take a greatest common factor of x out, which would leave us with a plus b. Okay, well, we're not actually done or factored yet. How do we know? Well, there remains a plus sign or addition sign that is not in parentheses. And so we must continue to factor this top left expression up here before we try to start canceling or multiplying together. The last step in factoring by grouping, as you may recall, would be to say that's really the same as a plus b, the matching factor, times x plus y, those little factors in front there. And that's all written over what we already have here, x minus y times x squared plus xy plus y squared. And everything on the right side should remain the same also. Okay, and now that everything is factored completely, how do we know? Well, there's no addition or subtraction that's not contained within parentheses. And the next step could be simplified a bit in that if I'm multiplying these two fractions together, really I'll be multiplying across the top and across the bottom. Okay, so I could rewrite the whole thing and smash this all together in one numerator and one denominator, or recognize that that's what would happen and just cancel things from where we are now. Meaning, this entire trinomial could cancel with this entire trinomial. This a plus b factor could cancel with this a plus b factor. And actually, that's about it. The x plus y here is all in parentheses. That's one factor, and there's no exact factor that would match it below. We have an x minus y and an x, but they don't match exactly. So we'll leave it as x plus y on top over x times x minus y. And though possible to distribute this x, it wouldn't be necessary. We could leave the answer just like this. In this next example, I'd like to demonstrate some division. So let's take this for something to work with. A times b plus 4a plus 2b plus 8 all over b squared plus 4b plus 16. And that entire expression divided by b squared minus 16 all over b cubed minus 64. Okay, so as we've been doing here, we'll do step one, which is to factor everything that we can factor. And so if we look at the numerator here on the left side, we have 4 terms. I'll try grouping maybe 2 and 2. And let me get that started before we go elsewhere. So it looks like a common factor of the first 2 terms would be an a. That leaves us with a b plus 4. And a common factor of the next 2 terms would be a 2, a positive 2, leaving us with also b plus 4. That's a good sign that we already have these parentheses matching, those binomials. And then below, we see what looks to be a trinomial. However, to try to factor this, we need 2 numbers that add to 4 and multiply to 16, and there are no such 2 numbers. So this doesn't seem to be factorable. Let's just copy it down for now and maybe see what else might happen. Now, instead of dividing by a fraction, as we know, that's the same as multiplying by the reciprocal. So I suggest doing this little flip now before we factor, otherwise it can be tempting to forget to do it at all. So I'm going to multiply now by the reciprocal of this, which is b cubed minus 64 over now b squared minus 16. Okay, let's continue to factor and simplify. Up here on the left, we have the last step of our grouping, which would be b plus 4, the matching binomials, times a plus 2, and that's all still over the unfactorable b squared plus 4b plus 16. Now that's being multiplied by, on the right, let's factor these. We have a difference of cubes up here. That would turn into, this is really b cubed minus 4 cubed. So using that formula would be b minus 4 times b squared plus 4b plus 16. And that'd all be over this difference of squares, b squared minus 4 squared, which would be the same as b plus 4 times b minus 4. Okay, so here we are. Everything's factored completely, except you might wonder what happened to this thing. Remember, we couldn't factor it, but now we see that it actually matches a factor up here. So we can keep that together in parentheses just to remember that everything cancels, all or nothing with those. And they're matching and gone now. b plus 4 is also match and cancel, and same thing with the b minus 4s. The only thing left standing would be this a plus 2, which would be our final result. Lastly, I'd like to do one more example of dividing or multiplying these rational expressions, and here it is. Let's say we had x squared minus y squared all over x to the 4th minus x cubed divided by x minus y over x squared divided by x squared plus 2xy plus y squared all over x plus y. Now you'll notice this is looking a little bit crazy with these two division signs here. We can still handle this using order of operations, which would say left to right with multiplication and division alike. So I'm going to start converting these divisions into multiplication before I even mess with the factoring, since we have two of them, and this could get ugly if we don't keep things organized. So what I'll do is this. Left to right would mean I have to evaluate the first two expressions and then the second. So I'm going to go ahead and do this first division, which would require me to flip over this second expression and multiply those together. So I'm just going to write that out as x squared minus y squared over x to the 4th minus x cubed times, here comes the reciprocal here, x squared over x minus y. Now really we still haven't touched this last expression, so I'm just going to bring it down as it was above. And now, again, before I even get to factoring, I'm going to handle this last division just so that we're hopefully safe with any kind of reciprocals before we start factoring and canceling. So I'm going to copy everything from the first two expressions down. But now, instead of dividing, I'm going to multiply by the reciprocal of the expression that's after it. So this would be x plus y over x squared plus 2xy plus y squared. Okay, so we've turned that ugly division problem into now a little bit better multiplication. Here we go. Let's finally factor everything and then see what will cancel. So it looks like we have a difference of two squares above here. This would be x plus y times x minus y. Down below we can take out a greatest common factor of x cubed. What would remain would be x minus 1. In the middle here, we actually don't have anything to factor, so we'll just leave it as is. But we could, just to be safe, put this expression in parentheses, the x minus y. It is one entire factor, and it's safer to see it in parentheses since nothing else is next to it originally anyway. And then lastly up here, this x plus y in the same way could be put in parentheses over. Now we could try to factor this. It looks like perhaps it could be factored because using even a guess and check method, plus y times x plus y will give us that expression. And you can check that x times x is x squared, xy plus xy would be 2xy, and then last times last, y times y would be y squared. Okay, so I think we're in business with factoring. Now we just look for matching factors and cancel them. So x plus y, those are gone right away. In fact, we have another x plus y over here that would cancel with another one over here. And let's see, x minus y's will cancel, and then x squared over most of these, right? This is really x cubed, but two of them are going to cancel with those two and leave us just with one of those x's. And I believe that's it. So notice nothing else is left standing above, so what does that leave us with? Well, just a 1 up there. Not 0, not nothing, it's just a 1. And then below, the only thing left would be an x times an x minus 1. And that would be our final result.